Hello. In this video, we will discuss about the single phase and three phase induction type energy meters. So here the contents of this video are a single phase energy meter, its construction and how it works, then phasor diagram of single phase energy meter, torque equation of the single phase energy meter, and in the last we will discuss about the construction and working of the three phase induction type energy meter. So here first let us see what is energy meter. So the meter which is used for measuring the energy utilizes by the electric load is known as the energy meter. The energy is the total power consumed and utilized by the load at a particular interval of time. It is used in domestic and industrial AC circuit for measuring the power consumption, and this type of meter is less expensive and accurate. But nowadays this meter is not used in field. The electronic energy meter replaced this induction type of energy meters, but the theory related to this energy meter is important for the further studies in the electrical engineering. So let us have look on the construction of the single phase energy meter. Now here in the figure, the various parts of single phase energy meters are shown. Here you can observe the pressure coil which is wound on the electromagnet. Copper shading bands are shown here. This is the shunt magnet. Then braking magnet is used here. One aluminum disc is there which rotates between these two magnets. The current coil is wound on this magnet, and one mechanism used for recording is installed is shown here. So if we observe, this is the input AC supply and this is the load. So the meter is connected in between the source and the load so that the power consumed by the load is recorded by this energy meter. So here if we see the main parts, they are driving system, then moving system, braking system, and registering system. So driving system means that the system that used to drive the disc when power is consumed. So moving system is used to move this mechanism. Braking system is used to control the movement of this disc, and registering system, which is not directly shown here, is used to register the amount of power consumed by this energy meter. So let us discuss one by one. So first, driving system is there. The electromagnet is the main component of the driving system. It is the temporary magnet which is excited by the current flowing through the coil. Here it is shown. The core of the electromagnet is made up of silicon steel lamination. The driving system has two electromagnets which are shown here. The upper one is called shunt electromagnet, is shown here, and the lower one is called series electromagnet, which is shown here. The series electromagnet is excited by the load current flow through the current coil like this. The coil of the shunt electromagnet is directly connected across the supply and hence carry the current proportional to the shunt voltage. This coil is called as pressure coil. The center limb of the magnet has the copper band. These bands are adjustable. The main function of this copper band is to align the flux produced by the shunt magnet in such a way that it is exactly perpendicular to the supplied voltage. So this is about the driving system. And let us discuss about the moving system. The moving system is the aluminum disc mounted on the shaft of the alloy. This disc is placed in the air gap between two electromagnets. The eddy current is induced in the disc because of the change of magnetic field. This eddy current is cut by the magnetic flux. The interaction of the flux and the disc induces the deflecting torque. When the devices consume power, the aluminum disc starts rotating, and after some number of rotation, the disc displays the unit used by the load. The number of rotations of the disc is counted at particular interval of time. The disc measures the power consumption in kilowatt hour, that is the unit of energy. So next is braking system. The permanent magnet, which is used for reducing the rotation of the aluminum disc or to control the rotation of the aluminum disc. The aluminum disc induces eddy current because of their rotation. The eddy current cuts the magnetic flux of the permanent magnet and hence produces the braking torque. This braking torque opposes the movement of disc and thus reduces the speed of rotation of this disc. The permanent magnet is adjustable, due to which the braking torque is also adjusted by shifting the magnet to the other radial position. And the last is the registering system, or we can say registration, or we can say counting mechanism. The main function of the registration or counting mechanism or registering system is to record the number of rotations of the aluminum disc. Their rotation is directly proportional to the energy consumed by the load in kilowatt hours. The rotation of the disc is transmitted to the pointers of the different dial or recording the different readings. The reading in kilowatt hour is obtained by multiply the number of rotations of the disc with the meter constant. So now let us discuss about the working of energy meter. So the energy meter has the aluminum disc whose rotation determines the power consumption of the load. The disc is placed between the air gap of series and shunt electromagnet. The shunt magnet has the pressure coil and the series magnet has the current coil. The pressure coil creates the magnetic field because of the supply voltage, and the current coil produces it because of the current flowing through it. The field induced by the voltage coil is lagging 90 degree on the magnetic field of the current coil, because of which eddy current induced in the disc. The interaction of the eddy current and the magnetic field causes torque, which exerts a force on the disc, and thus disc starts rotating. The force on the disc is proportional to the current and voltage of the coil. The permanent magnet controls their rotation. The permanent magnet opposes the movement of the disc and equalizes it on the power consumption. The cyclometer counts the rotation of the disc. Now let us discuss about the theory of energy meter. The pressure coil has the number of turns which makes it more inductive. The reluctance path of their magnetic circuit is very less because of the small length air gap. The current IP flows through the pressure coil because of the supply voltage and it lags by 90 degrees. The current IP produces flux phi p, which is again divided into phi p1 and phi p2. The major portion of the flux phi p1 passes through the side gap because of low reluctance. The flux phi p2 goes through the disc and induces the driving torque which rotates the aluminum disc. The flux phi p is proportional to the applied voltage and is lagged by an angle of 90 degree. The flux is alternating and hence induces an eddy current IEP in the disc. The load current passes through the current coil, induces the flux phi s. This flux causes the eddy current IES on the disc. The eddy current IES interacts with the flux phi p and the eddy current IEP interacts with flux phi s to produce the another torque. These torques are opposite in direction and the net torque is difference between these two. The phasor diagram of this energy meter is shown here. So here V is the applied voltage, I is the load current, phi is the flux phase angle of load current which is shown here. IP is pressure angle of load. Delta the phase angle between supply voltage and pressure coil. F is the frequency of supply. Z is impedance of eddy current. Alpha is the phase angle of eddy current paths. Capital E suffix EP is the eddy current induced by flux. Capital I suffix EP eddy current due to flux. Capital E suffix EV eddy current due to flux. Capital I suffix ES eddy current due to flux. So from this we can derive the net driving torque. So here the net driving torque of the disc is expressed as TD, that is the net driving torque, is proportional to phi1 phi2 into F upon Z into sin beta cos alpha, which can be written as K1 phi1 phi2 into F upon Z into sin beta cos alpha. In this equation, K1 is the constant, phi1 and phi2 are the phase angle between fluxes. For energy meter, we will take phi p and phi s. Beta is the phase angle between fluxes phi p and phi p is equal to delta minus phi. Therefore, driving torque TD is equal to K1 phi1 phi2 into F upon Z into sine of delta minus phi into cos alpha. But phi p is proportional to the voltage applied and also to the current flowing through current coil. So the equation for the net driving torque can be written as TD is proportional to K2 into V into I into F upon Z into sine of delta minus phi into cos alpha. Now if here F, that is the frequency of supply, Z, impedance and alpha are constant, then this equation can be written as TD is equal to K3 VI sine delta minus phi. And if we assume n is the steady speed, then braking torque can be written as TB is equal to K4 into n, and at steady state the speed of driving torque is equal to braking torque. So we can write as K4N is equal to K3VI sine of delta minus phi. So from this equation we can write the speed N is equal to K into V into I into sine of delta minus phi. Now if the delta is 90 degree, then this equation can be written as N is equal to K into V into I into cos of phi, and we know Vi cos phi is nothing but the power, so N is equal to K into power we can write. So total number here, the speed of rotation we can say is directly proportional to the power. So total number of revolutions can be obtained by taking the integration of this n with respect to dt. So integration of n dt will give us k integration of power into dt, so that is k into energy. So total number of revolutions are equal to power consumed by the load. So this is the torque equation. From torque equation you can find out that total number of revolutions of the energy meter is nothing but the power consumed by the load. So now in next section we will discuss about the construction and working of three-phase energy meter. Now let us see first what is three-phase energy meter. The meter which is used for measuring the power of three-phase supply is known as the three-phase energy meter. The three-phase energy meter is constructed by connecting the two single-phase meter through the shaft as shown in figure. The total energy is the sum of the reading of both the elements. So here how the connections of source side and load side are made are shown in this figure. So now let us see the working principle of this three-phase energy meter. The torque of both the elements is added mechanically and the total rotation of the shaft is proportional to the three-phase energy consumption. So here the two single-phase energy meters are combined to form a one three-phase energy meter which gives us the power consumed by the load. So now let us see construction of this three-phase energy meter. The three-phase energy meter has two discs shown here mounted on the common shaft. Both the disc has its braking magnet, copper ring, shading band and the compensator for getting the correct reading. The two elements are used for measuring the three-phase power. The construction of the three-phase energy meter is shown here in the figure. For three-phase meter, the driving torque of both the element is equal. This can be done by adjusting the torque. The torque is adjusted by connecting the current coils of the both elements in series and their potential coils in parallel, which is shown here figure. The full load current is passed through the coil, due to which the two opposite torque is set up in the coil. The strength of both the torques are equal and hence they do not allow the disc to rotate. If the torque becomes unequal and the disc rotates, then the magnetic shunt is adjusted. The balanced torque is obtained before testing the meter. The position of the compensator and the braking magnet are separately adjusted to each of the element for obtaining the balanced torque. So this is how this energy meter works. The overall operation is same as the single phase energy meter. So no need to explain this three phase energy meter in detail. So here we will stop. So thanks for watching. Thank you.